What really is a circle?
Something round, and
Circle is what you see when you get any shaped object and you spin it really fast.
a round thing.
I think a circle is a round object
When you
that is no
have a
use.
line
And
or a string and you fix it at
the
one
shape
end
of a
and then you
wheel.
turn the other end.
A circle is like a
Circle is
sun
an object
or a
with
moon.
an edge
Because the
equal
sun is
distance
round
from
and the
center
moon is
node
round.
point.
Throwing a rock in the water.
I think the circle is a shape.
Raised line with the
And it's constant.
No point,
Around the
and
score
then
is
we
the
get
width. Side to side is also constant.
circle is anything that is 360 degrees.
Diameter.
This book is about something that doesn't physically exist. Try to find a circle in nature, or even in the artifacts of human civilization, and you've embarked on an impossible hunt. Circles are all around us. We see them in nature, buildings, clocks, dishes, doorknobs, tools, machines. We have this gut feeling about a circle. We know what it is. Circles are everywhere around us, but are these circles that we know really circle? Consider a car tire. Is that a circle? Is it really round? What about the ridges? What about the fact that when we're driving, it's actually a little flat on the bottom? Does it really matter how round a circle is? I, for one, enjoy a smooth ride on a flat road. The wheel is nothing new, but it most certainly has improved dramatically over time. Rollers are likely a precursor to the wheel. They are a great way to move heavy objects with ease. The required effort to move an object can be reduced by 90% using rollers. But they come with so many problems. Notice how the object moves so much further than the actual rollers do. So this means that you would need to keep moving the rollers to the other side of the object so that your object doesn't fall off of the rollers at the other end. Another issue is that rollers have not always been just a Home Depot stop away. Logs seem like the obvious and readily available roller in nature, but since a tree is much thicker near its base, a log will not roll straight unless it is cut to a consistent diameter. So, you have felled some trees, evened them out, lined them up, and lifted a heavy piece of granite onto the rollers. New problems arise. Perhaps some logs are a little larger than others. Since a large piece of granite is not exactly flexible, the uneven pressure of logs can cause it to start cracking. Rolling logs over an uneven ground is not exactly easy either. And, to top it off, the rollers would slip out and roll down the mountainside if you were trying to head uphill. In making the pyramids in Egypt, it is quite likely that instead of moving stone over rollers, that they turned the stone into a wheel, using variations of a rope and pulley system to bring the stone up long ramps that winded around the pyramid. As the wheel became more developed, the question keeps arising: how round is round enough? It seems obvious that a triangle would not make a good wheel, but if we were to keep adding sides, we would eventually reach a polygon that most of us would identify as a circle. Almost 250 years BC, Archimedes decided that 96 sides is close enough. By inscribing and circumscribing a 96-sided regular polygon, he calculated that pi would be greater than 3.1408 and less than 3.1429. If we need to construct a circle with precision to a millimeter, we can construct a circle up to 10 meters in diameter without needing that third decimal place. Although this book really describes the search for an exact value of the ratio between the circumference of a circle and its diameter, which was later called pi, I decided to further investigate the question the author poses: how round is round enough? Thinking geometrically, A circle is officially the set of all points that are equidistant from a fixed point. Realistically speaking, a circle with each and every boundary point exactly equidistant from its center is impossible to draw or to make. But technology has helped make better and better approximate circles. Looking into the development of the wheel, the roundness of the wheel itself will of course have some impact on the smoothness of your ride. What is more important, though, is the axle. Whether the wheel turns around a stationary axle or the wheel is attached to a shaft which turns within an axle, there will be a situation where a round object rotates about another. With a wooden wheel and a wooden axle, there was a lot of friction between the two, causing both heat and damage. With the development in metalworks, the idea of a bearing between the rotating axle and shaft had a dramatic impact on the wheel. The ability to design and make small metal spheres that could be placed between the shaft and axle or between wheel and axle dramatically reduced the amount of friction. It is important that the materials used are strong enough to withstand the weight of a vehicle so that the cross-section of both bearings, axle, and wheel remain very good approximations of a theoretical circle. How round is round enough? Well, in terms of the bearings, the rounder and more uniform the better to promote rolling and prevent sliding. In terms of the circumference of the wheel, the more circular the better to give a more even ride on a flat road or track. Other technologies, such as rubber and springs, help smooth out those drives on rough roads. A history of the circle investigates the effect of circles in planetary motion, sine waves, music, and so much more. Let's take a quick look at the sine wave. Consider a point that moves about a circle. Watch how its height changes over time. This basic sine wave can be transformed and added to other sine waves. Different frequencies of this wave will make different tones. The wave made by a single circle is quite boring, actually. It doesn't really represent the natural world. Chords can be made by combining sine waves of different frequencies. But once we start combining these waves, we can make pretty good approximations of music, tides, and even our heartbeat. After reading about a history of the circle, I really started looking at the world around me in terms of circles. More specifically, things that go in circles. Things that turn. Many of them make our lives easier. Wheelbarrows, clocks, drills. Some just amuse us, like flying a quadcopter. I checked out a pottery studio and discovered the importance of centering a piece of clay on a pottery wheel before trying to form it into a dish.
The essence of making a pot on the wheel is to center this clay.
Right.
Right?
Yeah, exactly.
And that's the hardest part. The best way to think of the clay is it's a bunch of molecules, right, that you massage around to spread evenly.
Right. So those you're not going to get a perfectly round.
Yeah. Otherwise you'll get a wobbly thing. Not that wobbly is all bad. We cone the clay, so push it up a little bit, like that, and you can see it wobbles.
Is the spiral still there?
Yeah, a little bit. So see if you can get rid of it. Just sort of hold it and, see if you can massage out the spiral. Find the center, Maria.
Where?
To do it fairly carefully, otherwise you pull it off of center.
You kind of see the wobble a little bit, eh?
Yeah.
Yeah.
So one of the other things you can do is take this guy, you can perhaps de-wobble it a little bit. And that'll give you a smoother surface in general. There we go.
Okay, so now I can stop it, right?
Yeah. Takes longer to put on a handle than to make a mug.
This pottery lesson was followed by a lesson on the lathe. My nephew taught me how to make a spinning top out of a piece of wood.
Put this finger underneath. Just like this. And just.
Is it too fast? No. You can speed it up before?
Just do this and do it smooth all over.
I get actually just totally circular then, right?
When I initially fastened the piece of wood to the lathe, I suppose it was not quite tight enough. Fortunately, neither of us were injured when it flew off the lathe. My nephew was pretty sure that my spinning top was not going to be salvageable. I said, well, let's see what we can make of it. When we tightened the chuck the second time around, the axis of rotation through the wood had changed. As my nephew watched what was supposed to be the point of the top spinning in a circle when it should have appeared stationary, he shook his head and said, "This is never going to work." I was lucky though, because the new axis of rotation was still through the wood. At this point, he left me to tackle that chunk of wood on my own. With a bit of determination, I managed to chisel out a tiny spinning top. I think it spins pretty good, so I think I'll save it. Not that it would win a competition or anything. When it comes to the question, how round is round enough, it really depends on our purposes.
We're not making a very good circle.
For a pie, it doesn't really matter. For a wheel, it really matters. But then again, sometimes it doesn't. Sometimes it is just finding the center that really matters. And more often than we expect, circles might not be the answer to the problem. The ancient Romans initially used semicircle arches in their bridges, gates, and aqueducts, but eventually came to realize that segmented or flattened arches could better meet their needs. Pointed arches led the way in the tall structures that appeared in the Gothic architecture of the Renaissance era. Theoretically, the parabolic arch is now considered one of the strongest and is commonly used in bridges spanning long distances. To study the circle, both its properties and peculiarities, we learn information to help us in the real world. It can help us answer these questions in our own specific situations. Is an approximate circle round enough? Does round need to be circular? Is round right? And really, how round is round enough?